Hello everyone, in this lecture class we will discuss about the numerical integration. We started first part in the previous class. We have discussed in the previous class that the integration of the function from a to b or definite integral of the function can be written as wi f of xi I equal to 0 to n. Then it is called Newton-Cotes formula. Here we are using closed Newton-Cotes formula. Closed why? Because the nodal point, closed Newton-Cotes formula. Why? Because the end point of the interval AB also considered as included in the note. Okay, so this is closed Newton-Cotes formula. If A and B are not included in the notes, it will be the open Newton-Cotes formula. So in the previous class we have derived trapezoidal rule. We have taken n equal to 1, then we derived trapezoidal rule. What is trapezoidal rule? A to b fx dx equal to w0 fx0 w1 fx1. We computed the value of w0 as hy2 f of x0, and the value of w1 is also hy2, that is we have put, then we are getting the formula as hy2 f of a plus f of b, that we have derived in the previous class. Okay, this is trapezoidal rule. Why trapezoidal rule? Because it is showing the area of the trapezium. That's why we are on the basis of that we have given the name trapezoidal rule. Okay. Next thing is what will happen? It will take n equal to 2. When will take n equal to 2? One more thing in the previous lecture, trapezoidal rule. Here we are approximating the area of the function by a straight line. If A is this point, B is this point, and the area enclosed by the A and B, then we are approximating this by a straight line. N equal to 1 means what? We are taking only 2 points, x0 and x1, and this is the actual function fx, and here we are approximating it with the help of a straight line P1x, that is passing through x0 and x1. So the area inside this region, that is we can compute with the help of this formula, hy2 f of a plus f of b. So it is so the area, this is approximated by the area of the trapezium. Okay, when we are taking n equal to 2, that means suppose the function is y equal to fx, and we are approximating it by the parabola. Okay, y equal to p2x, that means a second degree polynomial. That is p2x. So this is the actual function, and we are approximating it with the help of second degree polynomial. That means the data points x0, fx0, x1, fx1, x2, fx2 are available. Okay. So integration a to b fx dx can be computed by I equal to 0 to 2 wi f of xi, where w0 is what? Integration x0 to x2. This is the point x0, this is x1 midpoint, and this is x2. x1 can be written as x0 as a, x2 as b, x1 will be what? A plus b upon 2. This is the midpoint. Okay, and the strap length h is what? H equal to b minus, length of the whole interval is what? B minus a, and since the distance between x0 and x1 is what? H, it is b minus a upon 2. Okay, so the length of the whole interval is what? 2h. x0 to x2 is 2h. Okay, so w0 is what? L0 x dx, or x0 is a, x2 is b. So the value of w0 is what? X minus L0x is what? The data points are available x0, x1, x2. So the polynomial L0x will be what? It will be a second degree polynomial that is passing through x1 and x2. X minus x2 upon x0 minus x1, x0 minus x2 dx a to b or x0 to x2, whatever you want to take, you can do integration. So what is coming out to be? The value is coming out to be h upon 3, where h is what? b minus a upon 2, that we have already written here. Okay, similarly we can compute the value of w1, that is L1x dx x0 to x2, the value is coming out to be 4h upon 3. Similarly compute the value of w2, that will be L2x dx h upon 3. So the integration from a to b fx dx is coming out to be h upon 3 f of x0 4h upon 3 f of x1 plus h upon 3 f of x2. Just keep in mind that here h is what? Length of the interval upon 2. So h by 3 f of x0 plus 4 f of x1 plus f of x2. This is a to b fx dx. Okay. So this is called Simpson 1/3 rule. Simpson 1/3 rule. Here h is b minus a upon 2. If we will compare this with the trapezoidal rule, in trapezoidal rule h is what? H is b minus a upon 2. Okay, so it should be clear what formula we are taking. So this is the thing. In this formula again I will want to repeat that this is the polynomial, second degree polynomial. It is cutting the function at 3 points x0, x1 and x2. x1 is the midpoint, and we are approximating this function with the help of second degree polynomial. Okay, so obviously the reason, actually the area that we have to compute, that will be what? That will be between the f of a, f of b and the y equal to fx. But since we are approximating y equal to fx by the second degree polynomial p2x, so the area now under consideration will be what? That will be between x-axis f of a, f of b and the polynomial y equal to p2x. Okay, so that is the reason. So what we have done in numerical integration, we have approximate the function fx with the help of polynomial. When n equal to 1, then we are approximating it by the first degree polynomial, that is a straight line. For n equal to 2, we are approximating function y equal to fx by the second degree polynomial, that is the parabola, we can say, and then we are integrating that function. Okay, so the continuous form of the integration is written in terms of the discrete form, or the integration here, left hand side is representing what? The integration of the function fx from a to b, that is the continuous form, and we are writing this integration equivalent to the summation of fx0, fx1, fx2 multiplied by some constant. That is what? That is the discrete form. So this form is equivalent to this form. Okay. Now let's do some example. Find the integration of the function. Example, fx equal to x square. Find integration by trapezoidal rule, and Simpson 130. Okay, so A to B, solution A to B, x square dx. When we have to find out integration by the trapezoidal and Simpson 1/3 rule, then we have some interval. Okay, let us suppose the interval is what? 1 to 2. Okay, so A is what? 1, B equal to 2. So integration of this function will be what? Exact integration. X cube upon 3, 1 to 2, it is 2 cube minus 1 upon 3, it is 8 minus 1 upon 3, that is 7 upon 3. Now trapezoidal rule, or we can say I trapezoidal rule. So what is trapezoidal rule? 1 to 2 x square dx equal to h upon 2 f of a plus f of b. So h is what in this case? B minus a. B is what? That is the upper limit, 2 minus lower limit, it is 1. A is what? That is 1. B is equal to 2, and function is x square. So f of 1 is 1, f of 2 is 4. So the integration value will be what? H is 1 upon 2, f of a is 1, f of 2 is 4. That is what? 5 upon 2. This is the integration we are getting by trapezoidal rule. That is 2.5. Here the integration, this is the integration value 2.3. Here by trapezoidal we are getting 2.5. So we are getting some errors. Now apply Simpson 1/3 rule. Simpson 1/3 rule. The integration a to b, this 1 to 2, x square dx equal to h upon 3. F of a plus 4 f of midpoint, a plus b upon 2 plus f of b. Okay, in this formula, this x0 is what? A, x1 is a plus b upon 2, and x2 is what? That is b. Now h upon 3. In this case, what is h? H equal to b minus a upon 2. Okay, in trapezoidal rule, h is b minus a. In Simpson 1/3, b minus a upon 2. Because we are dividing the whole interval a to b into 2 parts. Okay, so it is what? 2 minus 1 upon 2, that is 1 by 2. Okay, a equal to 1, b equal to 2, and a plus b upon 2y is what? That is 1 plus 2 upon 2, 3 by 2. So h is what? That is 1 upon 2 into 3. F of a, function value is what? 1, 1 plus 4, that is 1.5. Okay, 4 into 1.5 square, plus 2 square. Okay, 1 by 6, 1 plus 4, 2.25 into 4. The value is coming out to be let's check the value. What is the integration coming here? That is 1 plus 4 plus 2.25 multiplied by 4 divided by 6. That is 2.6. Just take the calculation. It is f of a plus I think it should be the value. Okay, so you can check this integration. Okay, so next is, so this is the integration we are getting via Simpson 1/3 rule. You can check calculation. I have done something, but I'm not getting time to complete it. Okay, next is error. Exact solution we are getting as 2.3. Okay, this is the exact solution. Exact solution. This is the approximate solution by trapezoidal rule. And now we are getting, this is solution by the Simpson 1/3 rule. How much error we are getting? If we say, if we check error, so how much error we are getting? Error is exact minus approximate. Exact is what? 2.3 minus 2.5 by the trapezoidal rule. Okay, so we are getting some error by trapezoidal rule. Error by Simpson 1/3 rule. Simpson 1/3 rule, we are getting 2.3 minus 2.33. Here we are getting less error in comparison to 0.2. Okay, here it is coming out to be 0.03. Okay, so in this case we are getting less error in comparison to this one. So how we can check, like in that way we can say that Simpson 1/3 rule is better than the trapezoidal rule. Okay, except this there is another procedure so that we can say which method is giving better result. Yes, we have another method. What is that method? If we are able to get error formula for the trapezoidal rule, how much error we are getting in trapezoidal rule, maximum error bound, or error bound in Simpson 1/3 rule, then we can say something about the error we are getting in our calculation. So next topic is what? Maximum error we can obtain in by using trapezoidal rule and Simpson 1/3 rule. Okay, so error in integration. Error in integration. So when we are taking n equal to 1, then how much error we are getting in Lagrange interpolating polynomial for n equal to 1. That means since we are approximating function with the help of the polynomial, so what polynomial we are using here? Lagrange interpolating polynomial. So how much error we are getting whenever we are getting Lagrange interpolating polynomial? So you know the error in Lagrange interpolating polynomial is what? That is x minus x0, x minus x1. Let us write the general formula. X minus xn upon factorial n plus 1 f of n plus 1 c. You can say c. C is what? That is the, it will depend on the interval. Okay, error, that n plus 1 data points are available. Points are available. When these points are available, then we are getting error formula in Lagrange. Since we are approximating function fx by the Lagrange polynomial, so whenever we have to integrate function fx dx, it is coming out to be the polynomial Pnx dx plus error in Lagrange polynomial, that is E dx. Okay, it is a to b. So this part is already computed. This is already computed. Now we are interested in to compute error. Okay, so let us take the case when n equal to 1. For n equal to 1, we got polynomial, first degree polynomial, and that is what trapezoidal rule. Integration of that 1 degree polynomial gives us trapezoidal rule. So how much error we are getting? That is, we are computing a to b. So for n equal to 1, what we are getting? X minus x0, x minus x1, because we are getting only 2 data points, x0 and x1. Factorial n plus 1, that is factorial 2, f of 2 dx. Okay, dx. That is the second derivative, a to b. Now this integration is containing one polynomial. Let us suppose this is gx and this is the function. Let us suppose this is the function hx. So multiplication of two functions. What we have to do here? We have to integrate two functions gx and hx. Hx is what? That is the second derivative of the function fx. Okay, or I can write it here as double dash. Okay, so if we don't know the form of the function, gx is known to us, that is a polynomial, but we don't know the function f double dash here. Okay, it could be any function, and suppose function is not given in explicit form, it is given in the data form, then how to solve this integration? If we are able to solve this integration, then error can be computed easily. So how to do that? Now we will take the help of Lagrange mean value theorem. Lagrange mean value theorem. What is Lagrange mean value theorem? Just a minute. Sorry. Now we will take the help of weighted mean value theorem, not Lagrange. What is weighted mean value theorem? That is used to compute the integration whenever it is a multiplication of two functions. Okay, so let us express weighted mean value theorem. What is mean value theorem? According to this weighted mean value theorem, suppose a function let gx be a non-negative or non-positive integrable function on closed interval AB if fx is continuous on AB, then integration a to b fx dx equal to f of t gx dx for some t belonging to the interval a to b. Gx is a non-negative or non-positive integrable function on a closed interval AB. If fx is continuous on AB, then a to b fx dx equal to f of t. Fx is continuous in AB, then the integration of two functions can be written as f of t gx dx for some t belonging to AB. Okay, let's close it here. One more statement we can use. Yeah. Suppose f belonging to C, a to b, the Riemann integral g exists on AB and gx does not change sign on AB, then there exists a number C in the open interval AB with a to b fx dx equal to f of t a to b gx dx. Okay, suppose f is the function that is belonging to CAB. F is a continuous function inside the interval AB. The Riemann integral of g exists on the closed interval AB, and gx does not change sign on the interval AB. Then there exists a number C in the open interval AB with a to b fx dx equal to f of t a to b gx dx. Okay, so this is mean value theorem. That means when the multiplication of two functions and those our condition is satisfied, then it can be written as f of t is belonging to the interval AB. Then it can be written as f of t and integration of gx dx. So due to that, by using this mean value theorem, we can write this in a simplified form, this integration in a simplified form. Okay, so let us assume this gx and hx. Okay, if any of the function gx is easy to check whether it is changing sign inside the interval AB or not. Okay, so the main important part is what? If we are able to check sign any of the function g, suppose g is, we are taking here polynomial, then we can apply this related mean value theorem. So what is our gx? X minus x0, x minus x1. Okay, and we are taking the interval here a to b, a is x0 and b is x1. Okay, gx, if we are taking any x inside the interval, suppose this is your x, so what would be the value of x minus x0? It is positive. What is the value of x minus x1? Negative. So g of x will be what? It will be negative. So it is negative throughout the interval. We'll take x here, here, anywhere inside the interval. It will not change sign inside. So gx is not changing sign inside the interval x0 to x1. So the integration x minus x0, x minus x1, f double dash t dx, a to b, can be written as x minus x0 f double dash t upon factorial 2, f double dash t outside factorial 2. This is Cx is the function. Here this C is different than this C. This C is the function of x. It is varying inside the interval. Okay, but if this function gx is not changing sign inside the interval x0 to x1, then by the weighted mean value theorem we can write f double dash c. This c is what? That is belonging to the interval, open interval of x0, x1. So this is a to b, x minus x0, x minus x1. A is clear, that is x0, b is x1. Now integrate this function. We are getting, after integrating, we are getting f double dash c upon factorial 2 into h cube, that is x naught minus x1 whole cube upon factorial 3. The value is coming out to be x0 minus x1 is minus h. So h cube minus h cube upon 12 f double dash c. So this is the error we are getting in trapezoidal rule. So error in trapezoidal rule is minus h cube upon 12 f double dash c. So this is the formula. Now error in Simpson 1/3 rule. Error in Simpson 1/3 rule. So what we are getting? Error in Simpson 1/3 rule. It is coming out to be, we are having 3 for n equal to 2, x minus x0, x minus x1, x minus x2 upon factorial 3 f triple dash cx dx a to c. Okay, why? Now we have to check. Let us suppose this is gx. Okay, so gx, we are taking here x minus x0, x minus x1, x minus x2. Now we are having this interval here. This is x0 point, this is x1 point, this is x2 point. X1 is the midpoint. If we are taking x here, if x belonging to the interval x0 to x1, then what is happening? X minus x0 will be what? It will be positive. X minus x1 will be what? Negative. X minus x2 will be negative. Then gx will be what? It will be positive. If x is belonging to the interval x1, x2, that means x is belonging to the interval x1, x2. I should write the open interval x1 and x2 we are not considering. So when it is lying inside this interval, so it is this side. So x minus x0 will be what? It will be positive. X minus x1, since x is lying on the right hand side of x1, it is also positive. X minus x2 will be negative. Why? Because it is lying on the left hand side of x2. So gx will be what? It will be negative. So what it concludes? It concludes that gx is changing sign inside the interval x0 to x2. When gx is changing sign inside the interval x0 to x2, that means weighted mean value theorem is not applicable. So, weighted mean value theorem is not applicable. When it is not applicable, that means there is a problem. Okay, what problem? We are not able to, will not be able to integrate gx and f double dash t, because it is a multiplication of two functions, and where f triple dash t doesn't, it is not clear what is this third derivative of the function, because it may vary according to the question. So what we do? So in order to resolve this problem, what we'll do, we'll take same interval x0, x1, x2, but we want to avoid change of sign of the function gx. So what we can do, we can repeat this point x1 again. So we'll take, let x0, x1, x1, x2, we'll take. Now repeat the point x1. So now we are having 4 data points. Then error will be what in this case? Error will be a to b. Now 4 data, 1, 2, 3, 4. So point x1. So now 4 data points are available. And 4 data points are available. Then what will be the formula? X minus x0, x minus x1 square, x minus x2, f 4 points, f4 c x dx upon factorial 4. Now new gx is what? This is your new gx. Okay. Now if you are checking, gx is throughout negative. Gx is out negative in the interval a to b. You take x anywhere inside the interval x0 to x2, then gx will be negative for all value of x. Okay, because x minus x2, that will be negative. X minus x1 square, that is always positive. X minus x0, that is x lying on the right hand side of x0, that's why it is positive. Okay, so gx is not changing sign inside the interval AB. So apply mean value theorem, weighted mean value theorem. Mean value theorem. Weighted mean value theorem. So what we are getting? We are getting an error here. F4 C upon factorial 4, x0 to x2, x minus x0, x minus x1 whole square, x minus x2 dx. The expression we are getting, that will be what? Minus h5 upon 90 f4 c. Here h is what? That is b minus a upon 2. Okay. So the point that we can discuss here, that is what? We are repeating the point x1 in the data point. Okay. Why we did that? Because we want to make gx not to change sign. Okay, so we want to make gx such that it will not change sign. That's why we have repeated this point x1. If we are repeating this point, it will not affect area. It will not affect area of the interpolated polynomial area that we have to compute it by the inside the interval AB. Okay, and error will remain unchanged. That's why we are repeating this point x1. Okay, so one more thing is here. In trapezoidal rule, h is what? That is d minus a. So it should be clear. But this h in trapezoidal rule, and but what is h in Simpson rule? So error in Simpson rule. Okay. So one more thing we can conclude here, as we have done the example. Suppose we have to integrate the function 1 to 2 x square dx. X square dx. What is the function? Fx equal to x square. If we'll find out by trapezoidal how much error we are getting. Error in trapezoidal rule. What is the formula error in trapezoidal rule? Trapezoidal rule. It is minus h cube upon 12 f double dash c. So the value is coming out to be minus 2 minus 1 upon factorial 2 whole cube. The second derivative of the function x square, it is coming out to be 2. So we are getting error here minus 2 upon factorial 2, that is minus 1. So error we are taking always in mod. So it is a positive value, we can take it. The error is 1. Okay. Error in Simpson one-third rule. If we are applying Simpson one-third rule to compute this integration, then how much error maximum we will get? That is what? Minus h5 upon 90, fourth derivative of the function. So what is the fourth derivative of the function? Is coming out to be 0. So the error is 0 in this case. That's why Simpson one-third rule give exact result for the fx equal to x square. But trapezoidal rule will give you error, that is 1. Maximum error. It is not like the case we are getting the error exactly minus 1. No, we are getting error that will be that is this is only the bound, not it will give you the exact value of the error. Okay, here we are getting error 0 because the fourth derivative of the function x square is 0. So with the help of this error formula, we can say something about the how much maximum error we can get whenever we are getting fx as any function. Okay, next is composite trapezoidal rules, that will discuss in the next class, and also some example based on error. Thank you.